sign diagrams for these four functions. Okay, so when you're drawing a sign diagram just from the function without the graph, for the critical value, you're looking for what makes this function 0. Okay, so you can see that if I made x negative 3 here, this bracket gets turned into 0, the whole function becomes 0, so therefore I say negative 3 is a critical value. And for this bracket here, if I made x1, the bracket becomes 0, therefore this whole function becomes 0, so we say 1 is a critical value. Okay, so that's how you get your critical values. You then simply need to substitute different values between these critical values to find out whether you get a positive or negative answer. So what's a value between negative 3 and 1? It's 0. So if I subbed in 0 here, it would be 3 times negative 1, which is a negative. So I get a negative answer, so I get a negative here. Now, because I have an odd number of powers, they're all to the power of 1, I know that the sign is going to change about the critical values, and there's my sign diagram. Let's take a look at this one here. Sign diagram for this one. Again, I look at what would make this function 0. So let's look at this bracket. And you can see that if I made x negative 5 on 2, this bracket would become 0. How am I getting that? You just do 5 over 2 and you change the sign here. So I know negative 5 on 2 is a critical value. Now, what value of x would make this bracket 0? Well, if I made x3, it'd be 3 take 3. That would become 0. The whole thing would become 0. So 3 is the other critical value. Okay? Now, all I have to do, once I've got my critical values, is sub in a value in between the critical values here. So that would be 0 again. So that would give me 2 times 5, which is 10, times 3, which is 30. It gives me a positive answer. So when x is 0, I get a positive answer. And I know, because they're to the power of 1, to an odd power, I know that the sign is going to change about critical values here. Okay, this one here, I was drawing, whoa, I really can't draw a straight line, can I? That's a bit diagonal. Right, here I go, okay, what would my critical value be? Well, how would this function become 0? Well, if I made x negative 2, it'd be negative 2 plus 2, turns into 0 squared, turns the whole thing 0. So I know my critical value is negative 2. Okay, now, let's sub in 0 again, which is going to be, look at this, I go 0 would be this side of negative 2. Okay, so that would become 0 plus 2, which is 2, so 2 squared, which is 4, times 3 is negative 12, so it becomes a negative. Now, because this is to an even power, this is a squared factor here, I know the sign will stay the same about the critical value, so that's the sign diagram there. Okay, and this last one. Okay, how would this function become 0? Well, if I turned x into 1, it'd be 1 take 1. 0 divided by anything, it makes this whole function 0. So I know that a critical value is 1. But also, if I made x here, if I made this denominator 0, alright, this function becomes undefined. So what value of x would turn this denominator to 0? Well, 1 over 2, so it would be negative a half. If x was a negative a half, there'd be 2 times a negative a half plus 1, okay, which gives me 0. So this denominator becoming 0 means this function becomes undefined, which means it's an asymptote at this critical value, okay? So when you make a denominator 0, it's an asymptote for the critical value, alright? So they're my two critical values. I now need to sub in. Let's sub in 0 because that's between negative a half and 1. If I subbed in 0, it's negative 1 on 1, so that's a negative answer, okay? I know that the signs are going to change. And so there is my sign diagram.